Okay, today we are going to talk about the TCP/IP attacks. Here's our group members: xpei, fgan, qliu, and this is xpei to talk about the sniffer. Okay, well, let's see. TCP/IP attacks includes a sniffer, IP spoofing, as well as floater, and port. Okay, a simple sniffer. As we all know that it is a cache data package software, and it could monitor the status of the network, data flows, and information transmitted from network. And the internet, as well as local area networks, consists of a huge number of services. You could use HTTPS for surfing web pages, SMTP to send emails, and use POP3 or IMAP to read emails. Most people should have heard that HTTP without S is insecure and should not be used to send one's bank account data or some important data. However, most protocols for daily use are plaintext protocols like ICQ or SMTP and IMAP. Unencrypted network traffic is the low-hanging fruit every attacker is searching for. Why should an attacker try to crack password if someone easily read them? Why should they just try to break into application server if they could hack the current admin section and insert his commands by using IP spoofing? With a network sniffer like TCP dump or Wireshark, the admin can illustratively demonstrate its user that one can read their traffic if they don't use encryption. Of course, we should have the authorization for the demonstration, as an admin should never invade the privacy of its user without authorization. We should only sniffer your own or the packets of the intruder to the network. Okay, next, here's a part of the code from the textbook. The tool sets the network card ETHO into the so-called permissionless mode. This instructs the kernel to read in every network packet, not only those addressed to the card itself. With the use of variable filter, you can set a PCAP filter expression. In the example, this filter ensures that only ARP packets get sniffered. Other possible filters will be TCP and port 80 to read HTTP traffic, and host 1 and 2 168.1 to see only AC, MP, and UTP traffic. And from that IP, the documentation of the PCAP filter language can be found on TCP dump org. The function leave opens a network interface for reading packets. We can otherwise read packets from PCAP dump file. The parameter we apply to OpenLeave are snapping to define how many bytes of the packet's payload should be read, a Boolean value for setting the promiscuous mode, and timeout in milliseconds beside the network interface to read from. Afterward, the packets are read from the network card in an endless loop. For every received packet, the function hello packet gets called. It decodes a packet with the help of the is decoder class. We use the is decoder here instead of the ARP decoder because the PCAP filter can be specified by the user with the use of the F parameter. Okay, next is PCAP dump. Okay, the parameters capture provides a high-level interface for the capture system, or data packets on the network, and even for the host could be captured to the mechanism. Well, we can know that the PCAP dump could also support capture packets to a local file to read information from it. And here's a code from the also from the textbook, we could see that we developed a script that will not display the call data package on screen in human readable format, but save them just into a PCAP DOM file for further processing by other network tools. In case script gets a file as parameter, it will try to read it and print its comment by utilization its work decodes. The function PCAP DOM opens a PCAP DOM file from writing and returns a dumper object, which provides a DOM method to write the header and payload of the package. For reading a PCAP file, we apply the method open offline instead of the further use method openleave, and give the file to open as exclusive parameter. The rest of the reading process is analogous. The example shows an improvement on the decoding of the packet data. We output our data and the packet at once by using the str method. Now we only decode the IP and TCP header instead and display the source and destination IP and ports as an example. The header or higher layer can be comfortably accessed by calling child method. That's it for the PCAP DOM file. Next is the password sniffer. Well, as we all know, it's a software which could scan. Of course, it could scan and records password and use it for broadcast on a computer or network interface. And it listens to all incoming and outgoing network traffic and records any sent of data packet and contains the password. Okay, the password sniffer installed on the hosted machine and scanning of the incoming outgoing network traffic. A password sniffer may be applied to most network protocols, including HTTP, Internet Network Access Protocol, Field Transfer Protocol, POP3, and TN, and related protocols, and carry password in some format. In addition, a password sniffer that is installed on a gateway or a server can listen or password that flow within a network. A password sniffer is primarily used as a network security tool for storing and restoring password. However, hackers and crackers use such utilities to sniff out password or illegal purpose. The danger of some of the protocols can most effectively be demonstrated with the help of the password sniffer. We could recognize that the encryption of their username and password is an act that endangers their privacy and they would like to avoid it from as possible. Okay, next is code. A part of the code. This time we flip the TCP traffic because the author is not aware of any UDP-based protocols that have a login or authorization mechanism. For a decoder, we additionally define IP decoder and the TCP decoder to extract the IP and the TCP header by applying the function handle packet. Therefore, we provide the package from the previous layer to the decoder through IP decoder, gets the ETH packet and TCP decoder and IP packet and so forth. The payload of the IP packet can be accessed ASCII string with the help of the method getDataAsString, which sometimes lead the ugly displayable character, especially when dumping binary data. Therefore, we first match the payload against a regular expression to make sure it contains the string like user password, or login. In contrast to regular password sniffer, our sniffer does not just search in protocols but in all TCP traffic and tries to detect other authorization mechanisms like session keys and cookies besides username and password combinations. So next is about detection. It's a sniffer detection. How to detect from them, and basically detecting if there is any sniffer in your network. The main feature of a sniffer that is used to detect them is that they place the network card in promiscuous mode, listening for all traffic. Typically, a sniffer is placed on a machine with a full TCP IP stack, which are well affected by this mode. And the bad sniffer could be rarely a threat for the security of your network. So it would be nice if they have any technique to detect them. Luckily, it's not that hard task. Just check on the internet interface to see if they are set into promiscuous mode. It would be more elegant to have a way to detect sniffer remotely. Fortunately, there are two ways to do so. Okay, the first one is overflow the network with traffic and continuous ping or connected hosts. In serial, hosts running a sniffer will respond slower due to more CPU usage for decoding the traffic. The second one, is to find sniffer from the distance. Is based on the trick that a system that is running in promiscuous mode won't reject any packet and react on them. Therefore, we create a APRP packet with a random unused MAC address other than broadcast and send it to every single host. Systems that are not running in promiscuous mode will discard the packet being not addressed for the mirror MAC, but sniffering system will send us a response. And that's it for the sniffer. And next, my friend will talk about the others about the TCP IP attacks. So
okay, let's talk about our project TCP IP attacks. And I'm going to talk about two types of attacks. The first one is IP spoofing. The IP spoofing is the forgery of IP addresses. The source IP is not the IP of the real network device the packet was sent over, but a manually inserted one. Attackers use this technique either to hide the source of the attack or to circumvent a packet filter or other security layers like TCP wrapper that block or accept connections depending on their source IP address. So let's take a look at the picture on the right side. We can see an attacker which has a real IP is 1.1.1.1, and it uses another computer which is on the internet. It uses this machine to send a package through internet to the target machine. So the targeted machine, which is the victim, it has recognized the source IP, which is 3.3 something. It is the trusted host, so the destination machine can respond this IP, and then the attacker will get to know that the 3.3 .3 something. This IP is the legitimate IP for the target machine. So eventually the attacker can use this kind of IP to attack the destination machine. So after we get the sense of the basic principle of IP spoofing, and we want to know how to protect it from this kind of attack. Here's the solution. The first is you can protect against IP spoofing by signing and encrypting all IP packets. A common case would be the protocols AH or ESP of the IPsec protocol family. This is a simple IP spoofing code example. It is kind of Python, written by Python. So we can see that we take two parameters, which is the source IP and the destination IP, and this line we create a packet that is included into an ICMP packet by defining IP method. This is maybe is a particular grammar in PCAP. So then we send the packet, we get the answer. If the answer is not null, we can show the answer, which get from the destination machine. So this is all about the IP spoofing attack. Next, we're going to talk about the SYN flooding. The SYN flooding is a variant of DOS, which is denial of service. It overflows a target system with spoofed TCP packets, which have the SYN set until the target system stops accepting new connection. This kind of attacks luckily is not such a big deal anymore, but maybe a couple decades ago it is really a big deal. It's really a dangerous attack. So how it works, let's take a look at this picture. This man who is wearing black glass, this is an attacker. You see that this man generates a lot of SYN packet sent to the server. As we know that the TCP three times handshake, the server will respond this SYN packets with the acknowledge packet, but the attacker, the client, which is controlled by the attacker, will not send back the package to the server. So the server will enter the half state status. So which is very consume the resource of the server. So the server will kind of block status, and in the meantime let's say a legitimate client, which is she wants to connect to the server, but the server, is blocked. Is still in the block status, so the server cannot accept the connection from the legitimate client. In this way, we say that the server is attacked by attacker. So this is a basic sense of SYN flooding. How to protect it is quite simple. For example, on Linux, you just activate SYN cookies. This is the solution to activate the SYN cookies. Also, this is a simple SYN floodder. It's a simple Python code. We also create IP packet which take two parameters. The first one is the source IP, the second one is destination IP, and we include this IP packet to a TCP packet. But initially we don't know what port is opened on the server, so we need to test one by one from 1 to 1024. We test one by one which port is opened, and if we found some ports are opened, we can send the list packet to this socket. This flag indicates the packet is a SYN packet, and finally we just send. We should say flood this tons of packets to the socket we found. Okay, this is the next we let our another group member to talk about the next part.
Okay, let's talk about my part. Talk about the port scanner. Is another TCP/IP attack. Scanner by port scanner is referred to by some people with ulterior motive to send a group of port scan news in an attempt to invert a computer and to understand the computer network service type. The attack can learn from where to explore the vulnerability to attack. In instance, a port scan includes sending a message to each port. Sending only one message at a time. The received response type indicates whether the port is in use and can be used to explore the vulnerability. Okay, the scanner is a kind of automatic detection of remote or local host security weakness of the program. By using the scanner, you can leave no chance to find the remote server TCP port allocation and the provision of service and their software version. It allowed us to understand the security issues that exist in a remote host directly or indirectly. scanner by using different remote TCP/IP port service and record the goal to give an answer. By this method can be gained many on the target host and variety of useful information, such as whether can use the anonymous login, whether they can be written in a FTP directory. If you can use the HTTPD telnet is to use root or nobody in the run. Let's talk about the critical code. First of all, the port scanner is a program that will just try to establish a connection port after port and afterwards list all the successful connections. This technique is not only screaming loud because it tries to make a full three-way handshake for every port, but also slow. It would be far more elegant to just send the SYN packet to every port and see if we can get the SYN or ACK or RST response back. It's exactly the tool we can going to implement now. Okay. Let's talk about the code. The tool scans only the first 1024 ports. Since those are the privileged ports reserved for service such as SMTP, HTTP, FTP, SSH, and so on. If you like, you can of course adjust the code to scan all possible ports. Optionally, the program will accept IP address to let the attack look like it came from different source. To be able to evaluate the response packet, it must still be possible for our host to receive the traffic or support IP. Let's talk about the port scan detection. How to protect your port from port scanning attack? We can use the port scanner detection program. It's a critical code. Remember, scan the port at a time in Unix format. Okay. That's all about the TCP/IP attack. That's it. Thank you.
Okay. Hope you enjoy.